What? What's wrong? Physics is too hard.
She wants to buy a new forget anything.
Never happy. Never happy. Alright. What flavour did you get?
Kit Kat.
Kit Kat. You wanted that one, didn't you?
Yep.
Yeah. Alright, we can write this down. We're going to have a look at waves now.
Wave and field and alpha.
I think we'll do it in this order, yeah. Because one of the experiments you have to do is on a wave. Is this your first time with an Easter egg?
Yeah.
And it's a good idea? Having a giant ball of chocolate, you approve of this? Yes. It's just something you would see in the UK and Ireland. You don't really have it in other countries.
Sure.
Yeah.
For real? Must be all the Irish workers there or something. So you've seen Easter eggs before then, isn't it right? Right, wave motion. You got that? Yeah. Okay, so not too difficult to begin the chapter and the semester with. Oh, I should say, I'll do things a little differently in this semester. So, in the last semester we had lots to do. Mechanics was big, electricity was big, materials was pretty big. So it meant we had only one tutorial per week. And then at the end of the semester we actually had to cut out the tutorial because we lost some snow days. Classic snow days. But actually in this semester I might even be able to give one or two tutorials a week. So, yeah, we'll see. This semester is more important for the exam because in section B you have 2 questions semester 1 and 3 questions in semester 2 topics. And because you have to choose 3 questions, it means, in fact, your section B could be only semester 2 topics if you wanted. Yeah. Okay, so let's have a look. There are 2 types of waves. First type we call transverse, or an S wave, and the second type we call longitudinal, or the P wave. So if you can write those down, and we'll explain what they are now. Longitudinal, transverse. Yeah. Okay. Does anybody know these 2 words, transverse and longitudinal?
I know.
Do you?
Yeah.
Tell me, what's transverse?
Transverse have some big
Yeah.
amplitude.
Okay, and longitudinal?
Small.
Not quite. You're half right and half wrong. Let's have a look. Yeah, it's the shape. So a transverse wave is a moving wave that is made up of oscillations. What's another word for oscillations? Boom, boom, yes. Vibrations that happen perpendicular to the direction of energy transfer. So what I mean is, if the wave is moving this way, the wave is going this way, the vibration is perpendicular to this direction, so the vibration is like this. Okay, so the wave is moving out like that. Kind of like an ocean wave. Yeah, what?
Quantum physics. Oh my god.
Oh yeah, I have to prepare your active listening for that thing, don't I? Okay, anyways. So, no, I have to. Transverse, it's perpendicular. Okay, so it's like the wave for the ocean, you know. That's a transverse wave. So if you can write this definition down, this is common definition in the exam. You know, what's a transverse wave? What's a longitudinal wave? Are your family gone back home now? Yes. Did they enjoy their time here? Was it their first time here? No, they've been here before. Yeah. Okay, you got that? Yeah? Yeah? Okay, so the next one now, longitudinal. So you might even be able to guess what is a longitudinal wave. Yeah, what's the difference, like words that might be different? Yeah, perpendicular could be replaced by parallel. So if the wave is moving this way, instead of vibrating perpendicular, it's vibrating parallel to the direction. So the wave is moving like this. Now,
same direction.
Same direction, yeah. Now it's hard to see this because when we see waves, we only ever really see the ones that are transverse. But in fact, the longitudinal is the type that the sound is. So my sound wave is actually the air is moving out like this. It's just you don't see it. So in a longitudinal wave, the particles do not move with the wave. The particles move parallel to the propagation. What's another word for propagation? Huh? Yeah, but it's a special type. Like in what do I mean what am I trying to say when I say the wave propagates? It's more than just oscillate. There's an extra meaning to it. Propagation. Huh? Yes, getting closer. Basically, in this case it's moving out, but propagation is just a verb that means the direction of the wave's movement. So you don't actually say the wave moves from A to B. You actually say the wave propagates from A to B. It's a different verb for waves. So anyways, it's parallel. This means that the particles move left and right, which in turn makes other particles start to oscillate. This creates the wave. The other thing about this type of wave is the air here vibrates, and it makes the air here vibrate, and then it makes the air here vibrate. But the air doesn't actually move. The air that's here stays here. You know, it's just the vibration passes along. That's all that's happening. So that's what I mean when I say the particles do not move with the wave. Whereas with a transverse wave, like an ocean wave, when the wave comes in, the water is moving with the wave. Whereas with a longitudinal wave, the vibration just passes along. So in fact, the particles stay where they are. They don't move with the wave. Now, of course, they could move with the wave, like you could get caught on one of the vibrations and move along. But the idea is they don't need to. It's just the vibration passes along. This creates the wave. So it's like this one moves left, right, and makes this one move left, right, and so on and so on.
Why they have different properties? Because they have.
It's how it's created. So the reason there's two different types is because of how you could make the wave, and we'll see that in the next slide. Okay, continue. Do you have this definition? Not yet. I don't think you need to write the left-right bit at the end, because that's just repeating the thing. You definitely have to write the sentence that contains the word parallel. But it's also important to note that the particles don't need to move with the wave, that they could actually stay in one place. This is the reason why sound doesn't move in a vacuum, because when the sound wave reaches the vacuum, there's nothing to take the vibration and continue it. Yeah.
Particle should be there.
Should be, yeah. 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 In fact, the sound wave travels faster in water because the vibration can move along better. Yeah, continue now. Okay, so here's two simple ways to make a longitudinal and a transverse. So a transverse, you could simply just take a string and just vibrate it up and down. And this will move to the right, and the vibration will be perpendicular. To make it longitudinal, you would take a spring and just compress it, and the vibration would travel through it in the same direction as the wave. So two simple experiments to make the two different types of waves. Do your very best to draw them.
Draw.
Yeah, come on. It's not that bad.
Why is it called wave exactly?
There's a synonym for longitudinal which is called progressive. So it's called P for progressive. I forget what the S stands for. Maybe seismic? I don't know. You drew that? Yeah? Continue? You have wonderful pictures? Yeah. Where's the hand?
Oh, here.
You didn't
Clear.
draw the hand.
Yeah, clear.
Is it clear?
Yeah.
Okay. Continuing, so the wave, there's different parts. Of course there's different parts. The different parts have different names. So, the distance, and I think you might actually know some of these already, the distance from the crest to the crest, at the top is called the crest or the peak, that's the wavelength. The top is called the crest and the bottom is called the trough. Yeah. And the distance from the center to the crest or from the center to the trough, that's called the amplitude. Okay, and the wavelength could also be measured from the trough as well. Yeah. So again, I'd like you to draw this with the names, please.
It's like sine graph.
It's exactly like sine and cosine graph.
Exactly.
It could be exact, yeah.
Amplitude is from the crest to the top, or?
No, it's only half that distance. Man, I'm getting hungry. I think it's like time for second lunch or something now.
I'm hungry too.
Yeah, we're all hungry, huh? No lunch?
I have enough for 3 eggs. Only 3 eggs.
What's the displacement and distance?
The displacement, as in the particles get displaced. I mean, it's not really a big deal. When we talk about displacement for a wave, we usually talk about the particles being moved from some kind of stationary position. Like when they're vibrating, the displacement is this distance. But distance is obviously not this. When we talk about the distance a wave travels, it's the distance from me to you. It's not really a big deal. Okay, continue. So, just some variables. Displacement, I'll use the letter x. it's how far the particle is displaced by the wave. So it's kind of like this distance. Whereas amplitude A is the maximum displacement. So if I go back here, maybe to this picture here, imagine I just put a little, take my pen, and I put a little dot here on the string. So in this picture, you would see this dot moving up and down, wouldn't you? Yeah. Now in this picture, the dot won't move because the string is tied. So it's not like this dot will move along. So if I mark with my pen a little dot here, I would see it moving up and down. This is its displacement. The biggest displacement happens here, and that actually, displacement is from here to here, that's the amplitude. And it can go under as well. I mean, originally the string was straight. So the particle started here and was displaced up to the maximum, which is the amplitude. The wavelength, we know this is the distance from the crest to the crest, or trough to trough. The period now, what's the period T here, do you think? Yeah, but I'm going to listen to the person using words, so go ahead. Yeah, it's the time for one cycle, one oscillation. So the time for one wavelength to pass. And the phase difference, does anybody know this one? Maybe an advanced word. You know it? What is it? Huh?
No.
What word are you saying?
Volt.
Spell that.
V-O-L-T.
Volt? No, I don't know what that is here. Okay. Anyone else? It's the time difference between the crest of two different waves moving together. So, imagine you have one wave moving here, and another wave moves beside it, and I'm standing here, and here comes the first wave, and there's a crest, and then I start my watch, and here comes the second wave, and the crest past me, and I stop my watch. It's the time difference for the two crests to pass me as they're moving. So if you have two ocean waves moving side by side, but they're not quite lined up, the phase difference is the time difference between the crests to reach me. This is actually important for waves, this time difference when you have two waves. Okay, you need to write these down. The next one is frequency, which is how many waves in 1 second. Yeah, 1 over t, correct. And finally, the speed is obviously how fast the wave is propagating. Okay, can you write these terms down, please?
One word.
Ah, come on.
Did these come up in the exam?
You mean like define? I'm trying to think. I have seen maybe 1 or 2 of these before, like maybe, but I don't remember which ones, maybe phase difference. But no, to answer your questions, they could ask you, like they could say, what is meant by the wavelength? They wouldn't need, these aren't formal definitions, they would just need you to like explain. And you could actually use the diagram to explain it. You could say the wavelength is the distance from here to here.
Okay.
Because these aren't definitions, these are just like vocabulary. You know. Did anybody go back home for the break? No? Everybody stayed here?
Yeah. Good.
You were so sad after your physics exam you couldn't go home. Yeah. Yeah.
Do we need the title for my essay?
Oh, what are you asking me? Do you need to put a title on your essay?
Yeah.
Of course.
Where should I put the title?
Normally, the title goes at the start, up the top in big letters.
Big letter.
Well, you know.
Beside it, everything's good. Like,
Don't put the title at the end. Don't put the title in the middle. You should put the title at the start.
start and middle side.
Yeah. What?
What?
What? You know what the word count is?
Do we have to put it on top?
Yeah. It said in the checklist to do this, didn't I?
Yeah, the top
Didn't
or
I?
the bottom.
Oh, okay. Oh, I don't care about that. Important.
What do we count it? We don't count the reference, the
Yes.
bibliography.
Yes.
Do we count like figure 1, figure 2?
No.
I have to control select, control select.
I just look at the word at like the Microsoft Word and the
No, but that
and
counts as the bibliography.
From introduction to
It
conclusion,
don't
right? The word count.
Yeah, equations don't count.
Huh?
What?
Equations don't count.
Yeah, that's correct.
Wow. How do
Microsoft
they
doesn't
count?
count the
The
equation.
Microsoft.
Yeah, it shouldn't count equations.
They don't count. Microsoft counts it.
Well, it depends. Well, it depends how you typed it, actually.
Yeah, doesn't
If
count.
you use the equation editor, I thought it wouldn't have counted.
Yeah.
Count as one word.
That's
It's one.
fine.
And-
That's fine. I just wouldn't want something silly where M1U1 plus M2U2 is counted as 4 words.
But M1U1 I didn't type in as an equation, right?
If you didn't type it as an equation, then it will get counted as 4 words. Because it'll think M1U1 is a word, and M2U2 is a word. No, just look. Look, if your word count is counting everything, then when you look at the bottom, just make sure it's more than 1,500. So, like, if it says 1,600 and it counts everything, fine, because you could be off by 10%. So it could be like 1,350.
You will minus my mark for doing the wrong word.
No, I won't. No, you must think me a small and petty man if I'm going to count your words and take marks away if you report the wrong word count.
But is it possible to write the S part of -1 without
Yes, it
using,
is. You can do this easily.
without using the
Yeah, without using the equation editor. You just press S minus 1,
yeah
highlight -1, like highlight,
yeah
and then click up the top superscript. And the symbol for superscript in the control panel, you have 2 buttons up the top here. And one that looks like this and one that looks like this. So you just type in S minus 1, then you highlight -1, and then click this button, and it will turn into this.
Oh, my program doesn't have.
No, it does. Somewhere it'll have it. Trust me.
Well, home section, intersection.
Or in the equation box, shift 6, then
Yeah.
in brackets.
Yeah. Using
Space.
this symbol. Yeah. But there's also a sneaky way to do it. This is what I used to do in school. I would type in 2ND, and it would automatically change this into 2ND like this, because it thinks I'm trying to write second. So then I would just go backspace, 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 and change this up the top to that, and then backspace, backspace, and change this into this. Yeah, this is when I was a kid, first using it, okay?
Can you put this to the power of your...
Oh no, I don't want this in the, I don't want this. You didn't do this, did you?
Like, how do you do that and enter in the equation mode and then it automatically...
Yes, that's what she said, yes. Yeah.
Did you change the Word file to PDF file?
Did I say to do that in the checklist?
Yeah. You don't.
I don't think I did. I want it as a Word file.
Word file.
Yes. Guys, don't be ridiculous, please. Don't make this harder on me, okay? Do we have this written down? Yes? Yes, we have this? Okay, continuing so. So, we haven't done any equations yet. Let's have a look at our first equation. Recall that f equals 1 over t. Okay, well that's not a new equation, but we can still use it. That's one of our equations. F equals 1 over t. But not only do we have this equation, we also have this new equation called the wave equation, which lets me calculate the speed of the wave if I know its frequency and its wavelength, where v is speed, f is frequency, and lambda is wavelength. Yeah. Yeah?
What's the unit of wave?
Unit of what?
Wave.
Oh, which letter?
Not the V, not the F.
The lambda. Yeah, because it's a distance from crest to crest, it's actually just meters. Okay. You got that? Yeah, Bruce? Yeah, I can continue? Yeah, okay. So, let's have a look at some examples of transverse waves, because in the exam they might, I've seen a question where they would say something like, what is a transverse wave, and give 2 examples, something like that. So what are some examples of transverse waves? Waves that move like this. Yes, but in fact you can't just say water, because that's actually not clear enough. Huh? Yeah, but again, we need more words to be precise about what we're saying is the wave. So you can't just say water wave, because there's many ways that waves could travel through water.
So right,
Yes.
Earth
Yeah.
to find the
Yeah.
core.
Find the core.
Yeah, you know, this is Earth. This is Earth.
Yeah. Yeah.
Like this.
Oh. Okay.
You know.
Let's do easier examples first. So the water one is fine, but you can't say water wave. You have to say ocean wave, because you're only talking about waves on the top. So you can say ocean wave. Good. What else is a transverse? You said light. Light is a transverse wave. Good. What else?
Right?
Yeah, it is. It's a transverse wave. Huh? Yeah, all the electromagnetic waves are transverse. Yeah. Anything else? Yeah, but what the heck is the word for that?
S something. S something. P something.
S something, B something.
I don't know.
Yes. Go on. Yeah, but I want examples that you actually see in day-to-day life naturally. So, okay, we have a couple. We have ocean wave, light wave,
Voice.
not voice, no.
Air.
You're close, yeah. The examples I have are light, ocean, but also waves in a guitar string. You know, if you have a string like on a musical instrument and you pluck it, this wave is a transverse wave. No, I'm not talking about the sound that comes off it, I'm talking about the actual string. Yeah. Yeah. Got that? Right. Longitudinal waves.
Earthquake. Earthquake wave.
Yes. But just the waves that are underground.
Underground.
Yeah, not the ones at the top. Just under the ground. Correct. You could give me that, yes. What else? Huh?
Sound.
Spring could be both, actually.
Sound.
Sound is another one. What else?
Yes.
Well, let's see what ones I put down, actually. Sound waves. Underwater waves, like underground waves, and waves in an oscillating spring. The examples you are given are fine. You just need to put in one or two more words just to make it a little clearer. So when you said earthquake, in fact earthquake could be both, because at the ground level it's transverse and underground it's longitudinal. So you would have to say underground earthquake. What's the name of an earthquake that happens under the water, under the seabed? Is that called a tsunami, isn't it? I think so, yeah. Okay, you got that? Continue? Yeah? Okay. Right. A boy is sitting on a boat which is tied to the dock. The boat bobs up and down at a rate of once per 2 seconds, and the boy judged the distance between the peaks as 4 meters. How fast are the waves moving? So, just to be clear here, here's this little boat sitting in the water, and it's tied, so it's not going anywhere, and it's going up and down once per 2 seconds. So that means t equals 2 seconds. And the frequency we can get, and the wave is coming in, and you can see that the distance between here and here is 4 meters. So this is enough information for you to work out how fast this wave is moving. I would like you to try and calculate this using the formula I gave you. See what you can get. I pretend to take a little bit longer. I'm very tired. No, more time than that. I need more time than that. Thank you. Yes. Yeah, it's hard, this question, isn't it? Yeah. Oh, very. All right. Do you have answers? Yeah.
No, it's hard.
Oh, good. Yeah. No, take your time. It's okay. All right. Let's have a look. So the V is lambda f. Do we know the lambda? We do. Do we know the f?
Yeah.
Yeah, well we could know it, because f is 1 over t, which is 4 times 1 over 2, which is 2 meters per second. So, very hard to begin semester 2 with. Okay.
Oh, done.
So these are the 3 questions I want you to do, and you can do them. Yeah, you can do them now. They'll only take you a couple of minutes, and then no homework. So if you can just, these are the 3 questions for homework. But if you can just do them now, you can take a picture on your phone if you like, or it's going to be uploaded after the class, isn't it? It is. I think I'd have these PowerPoints on Moodle as well.
No,
There's this one, yeah. But I think I have the link for this slide.
Oh.